welcome to PyCon 2018, and Brand, welcome as well. Without much ado, I would like to, just introduce you and get on with it. Over to you, Brand. Thank you.
Thank you very much. Hello, everyone. Thanks for coming. This talk is demystifying LoRaWAN with PyCom, so hopefully you're in the right place. I'm Brian Danilko. I have a business contracting and have for the last 25 years or so called Likeable Software. But the nice thing about this particular work is that I actually had a client. And that meant I could actually work on this and charge somebody. So that's IntelliKey, so that's why I put them on the slide as well. I'm really glad they did, because even though I'd been using Python for years, I hadn't discovered MicroPython and PyComs until this project came up. So that was something I'm very glad that's happened. About myself, I said kind of everything just by saying I've been programming for about 25 years, 30 years now, professionally. So I'm one of the old hands at it. But what I like is learning new things. And with Python about 10, 15 years ago, with PyCom, MicroPython in the last 6 months, with LoRa and LoRaWAN, there's always new things coming up. That's good, but you also continually find out how little you know. And that's really the motivation for this talk, is that when I started on this project, first I started with LoRa, and I'll explain the differences between LoRa and LoRaWAN. I learned heaps, I read the specs, I read the data sheets, but I was still quite confused. And there wasn't anyone that I could ask, really. So I did as much research as I could, but it came down to trial and error and looking in the code, looking in the source. So the motivation of this talk is that I'd like to pass on some of these, some of what I've learned, and also I'm going to have a bit of a plea for, in the Internet of Things, as we scale up, we're going to get new problems. So if we start using some of these resources like LoRaWAN well, we'll scale up a lot easier. So that's the, and in fact, there is a bit of a problem with PyCom, is that it makes things so easy. So MicroPython and PyCom, you start in 20 lines of code, you're communicating over this wireless network. So it's pretty easy just to say, I'm done. I've done it. But doing that means that you won't be doing it very well, and you could be affecting others because it's a shared resource. Anyways, let's get to the interesting bits. So the goals for this talk are, I'm going to go through a little bit about what LoRa is and what LoRaWAN is, because a lot of people get confused. How many people are using or know of LoRa? Oh, quite a few. That's great. LoRaWAN, are you using that? Or that's what I find normally, that there's a lot more people using LoRa, because that's kind of the base, and then going on top of that is LoRaWAN. And starting with LoRa is very simple, and that's great. So I'm going to look at the differences between the two, and then I'm going to go to those misunderstood areas, those things that I found difficult myself, and try to give you a bit of a jump start. But LoRa and LoRaWAN is a big subject, so it's just going to be this whirlwind tour. But I'm definitely happy to take questions at the end of this and any time during the conference. And the last one is that plea to use LoRaWAN responsibly, because it is a shared resource. And if we start clobbering everyone else, we won't be able to scale up for IoT. I'm only looking at the end nodes, so the little guys doing the communications, the motes or the end nodes. to a gateway, and we'll look at that. But there's a whole nother layer on top of that, which is the data storage and the joining, deciding who gets to join. I'm not going to look at that, basically because I don't know exactly how it works. So we'll leave that. OK, so what did I do? I got two LoPi modules, and as soon as they arrived, late of course, but they did arrive. When they arrived, the first thing you want to do is make a LED blink and have them talk to each other. So that's what I did. And here's 25 lines of code that, that creates a ping pong sort of communications transfer. So you can see how easy it is with PyCom, which is using MicroPython. We just import the module called LoRa. So that's something that PyCom's added. Import socket time. And then just open up LoRa with this mode LoRa.LoRa, which is saying that this is LoRa, not LoRaWAN. Set up a socket, and then we send or receive to that socket. So one of the end nodes will actually, when they start it with the name equal main at the bottom, will call ping, and the other one will call pong, and they will be transmitting back and forth. So that's what I was saying. It's almost too easy, because and this actual this example, I didn't make it up. This is directly from the PyCom documentation, and there's where it is. But the tutorials don't go much beyond this, and that's the problem. A couple little important points, and I'll be bringing them up during the talk, is make sure you connect your antenna, because they keep having these warnings all through it. If you're using the LoRa transceivers without the antenna hooked up, you could break your hardware. That we want to avoid. Lots of examples, 25 lines of code. We've already got it working. And you can even, and I've done this, you can move your units kilometers apart. Line of sight's kind of nice, but kilometers apart, and have an antenna on them, and they will still work. So that's one of the benefits of LoRa. OK, so that's the important point. Don't break your hardware. OK, just some quick background. LoRa itself, so LoRa is that transport layer. And it's actually patented. And it was developed by this Cyclo. I didn't even know that. But when I was doing some research, I saw that it was developed by Cyclo, because now everybody thinks of it as a Semtech technology, because they bought the patents in 2012, and they produced quite a few chips for the LoRa transmission, so the transmission and decoding. It uses something called a chirp spread spectrum to transmit information reliably, but using low power. It's another technology I don't understand totally, because I'm more a software person, but it sounds like these are chirps that are just increasing in frequency over a particular time, and where they start the chirp is the different value. There's a couple really good websites on it showing some MATLAB simulations of it that are quite neat. OK, so LoRa, it allows you to use different power levels, frequencies, bandwidths, 125, 500, and spreading factors. And spreading factors are part of that, the chirp, where it just doesn't decode to more values or less values. But with all of these, you have trade-offs. If you use lower power, you don't get the distance. Time on air, that's an important one for fair use. So that's something we'll be looking at later. So right now, really, the big things is power. We're always trying to minimize our power, and we're trying to maximize our distance. So LoRa allows you to change all of those values. Just an interesting little factoid. Hedy Lamarr, who's a movie star in the 40s, 30s, 40s, 50s, she actually did some work on spread spectrum communications. It seems that she wasn't given very difficult roles, so she was bored. And she had a very scientific mind, so she did some of the early work. That was just an aside, by the way. Okay, so LoRa. We've been talking about LoRa. LoRaWAN, that's what we want to get to. So they're both long range. That's the LoRa part. Both low power, and both use low-cost hardware. And that makes sense, because LoRaWAN is on top of LoRa. So what it adds is this wide area network on top of LoRa. And one problem is that that introduces a lot of complexity. So, so it's a lot more complex. But on the positive side, that complexity is 90% handled in this thing called the stack. So and the stack is just the software that actually handles the protocoling needed to be LoRaWAN, needed to be compliant. Most of it. Okay, so LoRaWAN. So what are the features? Why do we want to use it instead of the simpler case? Well, it connects us to the internet. So already we've got a compelling reason to use it. So if in Internet of Things you want to dump information on the internet, you're going to get there with LoRaWAN. And it does it by using gateways. So it actually transmits to a gateway that is connected to the internet, which then passes it onto network servers. It also has a lot of other nice functionality. Encryption. So we have secure transmissions over the air. It can control which devices can join the network. It also has this MAC layer, which is used to set channels, power levels, frame counts, so a whole bunch of things. I'll look at that in a minute. And it also has something that's a bit scary, confirmation and retry. And when we look at the fair use, I'm going to be suggesting that if you don't have to use this, don't. Because all of a sudden you double or more all of the transmissions. And that's bad from power, and that's bad because you're clobbering the airways that other people might want to be sending real data for. So, okay. So you can tell I'm more of a code sort of person and not an artist. But this shows two, for example, low Pi boards. And so this is that original program, the ping pong. And it's just the two applications doing one calling ping, one calling pong. And then through the LoRa device, which is managed by PyCom, we get the transmissions. Now, when we do LoRaWAN, what we have is we have a user application on top of the LoRaWAN stack. And then it's using the same LoRa beneath it to actually send the data. So it's still LoRa going over the airwaves. And then the gateway, so an application we don't have to write. There's lots of gateways out there. It's actually taking the data from the stack and sending it up to the internet and communicating to these things called network servers, or services, sorry, which is they do things like store the data, but they also do what's called joining, a joining server where they check to see if the device that's trying to send the data, can they send that? Do we allow them? So all of those things are just normal programs in the web. And of course, our life is a lot easier because of that red layer, which is PyCom and MicroPython make it much easier to communicate to that stack. Okay, something else about LoRaWAN is the topology of LoRaWAN is that you've got a star network. And the idea there is that you have a central server. In this case, it's our gateway. And we all connect with a single hop to the gateway. So, and then the gateways are connected to the internet. So that's called a star network. And so here's an example of 3 different modules communicating to a single gateway. And then that gateway is communicating to the internet and the network servers. And now I've actually got a picture, so it's a little nicer. How the gateway connects to the internet, by the way, it can use a wireless method itself if it needs to, depending on how remote it is. But typically what you'll have is you'll have a gateway that's actually in a location where it's got power and it has connection to the internet, a wired connection. So that's quite typical, but it doesn't have to be. It could actually be using a mobile link. It could be using anything. Something that's quite neat, though, is we were talking about a star network. What happens if you have 2 gateways? Well, you actually want more gateways for reliability. So you would actually like your modules to be received by multiple gateways. So if one of them you don't quite reach, you'll get the other. And so in this case, number 3 is only going to gateway 1 because that's the only one it's reaching. But 1 and 2, they don't decide, they just transmit. And both gateway 1 and gateway 2 receive. And that's fine. And the only thing that has to make a decision is if the gateway wants to communicate back to one of the units, it then has to decide, like in this case here, PyCon module 2, the gateway and the network servers, they decide which gateway to send the response through. And they do that just by looking at the link quality. So basically, which one's closest, they send back through it. So they don't send through all the gateways. And that's an optimization strategy because whenever anybody's sending, they're clobbering everyone else. So we want to minimize that. OK. I'm going quite quickly, but I've got a lot of slides just because I wasn't sure of the knowledge levels. But again, ask me any sort of questions. So I've mentioned the stack, and we're probably used to stacks from all like other communications protocols and such. So same idea. It's actually the part of the code that handles the protocol. And just some background. We have a BSD licensed reference implementation that was originally done by Semtech, and now it's done by Semtech and StackForce. And it's currently at a version 4.4.2. And the only reason why I mention that is if you start to talk to network providers, they're going to be saying, oh, what, are you using 4.4 or up? And that's, and it's just because the actual protocol has expanded over time. So you have to make sure that you're using a high enough protocol that the network supports or expects. That's a better way of saying it. PyCom itself periodically syncs with this, with the development that's being done on this, this reference stack. Now, we also have heaps of, how am I doing? We have heaps of standards. That's the thing about standards. You've got so many to choose from. And in this case, there's a 1.01 LoRaWAN that I think is about 3 years old now. There's a 0.2, 0.3, and a 1.1. The problem is that most gateways are only supporting the 1.01 or 1.02. So it's something you could get caught with. OK, on this Whirlwind tour, another thing that you will hear about is joining a network. And the idea of joining a network is authenticating yourself to the gateway and the network services and exchanging keys. It's a key exchange. So they can say, no, we don't want you, or we do, and exchange keys so that everything's encrypted. So there's 2 different ways of doing that. One's called over-the-air activation, OTAA, and the other's called authentication by personalization. And the difference is that the OTAA, you're able to manufacture your devices with the same keys in it. So you have these application keys that you put in it. But the very first time when you join, the network services have to check that. So there's some queries back to some computers somewhere. So it takes a bit of time. It takes, typically it takes 5-6 seconds. So some people don't like OTAA because of that, because there is a faster way, which is the ABP. But to use that, you have to pre-generate the keys and put a different set of keys, a network and session key, in every device you put out there. So it's quite fragile doing it that way. And the other thing, and this is something when I was originally doing my project, I was thinking, well, 6 seconds, that's too much, because every time you start up, there's an extra 6 seconds. But the reality is that it's only the first time, because you cache the keys that you're given. So the next time, it's exactly the same as the authentication by personalization. And here's the code to actually join with OTAA. Wow, that's not centered, is it? And you can see where we've got two app keys. And notice on that LoRa line that we're using mode LoRa.LoRaWAN. So this is saying use the whole stack. And then the other interesting thing there is the caching. So the LoRa module on PyCom has an NVRAM save and restore function. And so this code, just this amount of code, will actually say, if I've already cached it, I don't need to actually do the join. If I haven't cached it, do the join. And then that takes a bit of time. But the thing that you have to remember to do is before you go to sleep, save the LoRa NVRAM, or else it won't work. So that's another gotcha that's quite easy to overlook. And the other question is, where do you actually get these keys, like those app keys? Well, this is specific to whichever network you're using. So an example of a network is the Things network. So, and it's great. I really like the Things network. One, it's free, and easy to use. So, so it's just through the web. I'm running a bit low on time, so I'm just going to, OK. Something else that you might hear about is these LoRaWAN classes. So basically, I only worry about Class A, because Class A is the lowest power class. And just to show you what that looks like, the idea of Class A is that when you do a transmission, you can only receive a transmission downlink transmission, at a time, like this receive slot 1 and receive slot 2, those are windows for when the gateway can communicate back to you. So, and that's the only time. So you can sleep every time except for that and reduce your power usage, save your battery. So that's Class A. Class B and Class C, they just provide for more opportunity for the network services and the gateway to communicate to you. So, but from an IoT or Internet of Things thing, I really want it to be as fast and as low power as possible. Messages, I'm going to skip that. It's just basically uplink is what you send to the gateway. Downlink is what comes back to you. One interesting thing, though, is that there's counters. There's counters which have to always increase. If not, the message is thrown out. And this is a way to stop from replay attacks, which means that LoRa NVRAM save is really useful because it stores your counters, and when you restore it, you get the counters the way they were, so you can just keep incrementing them. Okay, that's an important point. Okay, here's I'm going to go over a bit and and answer questions later. One of the big problems I found was that what people didn't realize is that you have to make sure that what the gateway's listening on is what you transmit on. That's you know, a no-brainer. But we have these regions where different regions have different frequencies that they'll be listening to. So you have to be aware of that when you set up your device so that it's actually transmitting on the same frequencies that the gateways are listening to. Now, in Australia, we use the AU915 and the AS923, two different ones. And again, you need to know what your network provider, like who's providing the gateways to you, uses. But we have another problem. With the AU915, it actually defines 72 channels. So with the 72 channels, you, yes. So, but the problem is that the hardware and the gateways typically only listen to 9. So you could be transmitting on all of these channels, and you just keep getting dropped packets. And so here's a bit of LoRa code that actually says, OK, we only use channels 8 to 15 and channel 65. So anyways, I've run out of time a bit, but my plea is fair use. And the idea of that is that IoT, we want to scale up. We want to have tens of thousands of these devices. And the only way we can do it is by making sure that we are transmitting as little as possible. And so here's some things that you can do. You want your data rate to be as fast as possible, which is something you can tune in LoRa. So it reduces the time that you're on air. You want to leave as much time between transmitting as is practical. And do you really need confirmed transmit? Try not to need that. One way is to have your application be able to take downlink messages just to say to resend a frame. Then you don't have to have the confirmation. So I said it was going to be a bit of a whirlwind. And yeah, I've got some references. This will obviously be up on the web, so you can have a look at that. But some references and some thanks. PyCom, MicroPython, the Semtech stack maintainers, PyCon AU 2018, and the people that actually paid for my work. Thank you. Sorry.
Thank you, Bran. I'm sorry we don't have time for questions. Would you like to take one at least?
Sure. Oh, please.
Any questions?
This is mainly on the hardware. Do you know if those modules actually support mesh networks, or is it just star topology?
LoRa can use a mesh network, and in fact, PyCom has brought in a mesh network, but it is not strictly LoRaWAN. So LoRaWAN is really the protocols. And the point of LoRaWAN was that you actually had a single hop, because as soon as you do multiple hops, it means more transmission. So what's better is to get more gateways so that you actually connect to at least one gateway with a single hop. That's actually a better investment. So yeah, mesh exists, but it's only currently used at LoRa level. That's not in the LoRaWAN spec.
I'm sorry, we have run out of time. But you can catch hold of him outside as well.
Definitely.
Yeah.
Oh,
thank you very much, Brian. And this is a small token of appreciation.
Oh, thank you.
From us.
Oh, thanks.